Hello everyone, welcome again. Today we are going to solve a security engineer room, which is Introduction to Cryptography. There are 9 parts for Introduction to Cryptography. Let's begin with the first one. Here, do we need any answer? Yes, guys, here we need an answer. But how we are going to do this? You have received the following encrypted message, like this. You can guess that it's a code. Who said it? We have to visit this website to solve this question and paste this value, all of these value, into this place. Let's click on solve, and we have we have lots of answers, but we can guess the true answer from the order. Let's try this answer. Actually, the question was asking for Aldo, right? Yeah, who said it? Okay, who said it? Miyamoto Musashi, Misumoto Manunchi, but the answer is Miyamoto Musashi. We can find it with the first try. Miyamoto Musashi. Let's go with the second one. Do we have a question here? Yes. Decrypt the file code 1 encrypt. Okay, here we have some decryption operations, and to these operations correctly, let's first open our attach box, open our terminal, and go to these rooms, I guess, here. Yes. For task 2, is it task 2? Yes. Anyway, we can see the path here. Decrypt the file code 1 encrypted using this one, with decay this one, and using GPG. What is the third word in the file, and what is GPG? We can encrypt a file using GNU GPG using the following command. Privacy GNU GNU Privacy Guard, also known as GPG, implements the OpenPGP standard. Anyway, to solve our first question, we have to decrypt it, right? To decrypt a text, we can use this command. You can decrypt using the following command. Let's copy it, guys. And to do that, which is the directory? Which one? The necessary file. Okay, task 2. Let's go to the task 2 and paste this command. Before that, let's make ls. So as you can see, we have 3 files here. Let's now paste it. The output can stay the same, but the decrypted message should be different, right? We have to decrypt this one, code 1 txt GPG. Let's type code 1. Okay, GPG, the output name, actually original message text txt. Okay, we can keep it like that, but the decrypted message will be different, which is our target. Anyway, let's paste it. It asks for password, so what can it be? The password is actually the key. Here we use the key as a password. Let's copy this key and paste it here. Why? Because this file is encrypted and it needs a key. Okay, now we can see our original message txt. Let's read it. Original. Do not waste time idling or thinking after you have set your goals. The third word is waste, which is the true answer. Let's go with the second one. Decrypt the file code 2 with the same style, but this time we have to use OpenSSL. What is the third word in the file? To decrypt the file with OpenSSL, which command should we have to use? We can encrypt. Okay, where is decryption? Okay, consequently the decryption command becomes like that. Let's copy it, and this time we have to decrypt code 2. Okay, come here, paste it. What is the parts that we have to change? It can OpenSSL, IS-256, CBC, they can stay in the same. There is an iter function here. I think we don't need it. What does it do? This iter one. Okay, we can see its function. So probably we have to keep it like that. Okay, but we have to change this part. Okay, encrypted message. Come here. Encrypted message has to be code 2 and output original message. We have already an original message txt. Let's make it original message 2 and then press enter. It needs a password. What is the password? Is this one? Come on. Oh, it doesn't come like that. Okay, copy and paste it. Let's make it ls. Can we see it? Yes, original message txt. The operation has successfully completed. Original message 2. Okay, there is a problem here. You can see we can't read, we can't see a clear text here. What is the mistake that we did? Bad encrypt. OpenSSL. Decrypt. Actually, decrypt, yes. Code to original. Okay, let's check it. To iterate 1 times the previous code. Okay. We can decrypt the resulting file using. Yes, guys, we don't need any iteration here. It is a mistake that we did. The real command has to be like that. OpenSSL, these standards, decryption in this file, output original message txt. If you need an iteration, then you have to use these parameters with these. Okay, we cannot use the password based key derivation function too. Okay, anyway, let's come here and let's remove the original message 2. Okay, and then paste our command again. Let's copy it, paste. Okay, decryption with this file code 2 and output, let's say 2 again, and the decryption key, it is our password. Actually it's a key, but we can call it a password. Warning, deprecated key derivation used. Okay, let's read the original message 2. As you can see, now we can read it because we can see a clear text here. The pseudoscience, the question was asking for the third word. Let's check it. Yes, it is science. Last question, decrypt the file code 3, encrypted using, okay, no problem. We have to use GPG this time. What is our GPG command? it can be our actually there has to be an algorithm, right? So this time we have to copy this comment. Okay, why? Is it symmetric? Let's check it. Decrypt the file. Okay, using this with decay. Okay, actually does it has to be symmetric? Okay, we will try. Come here, paste it. PG armor symmetric cipher algo. What is the algorithm? Camellia 256. Let's paste it. And is it code 3, right? Yes. Code 3.txt. What? Truth all 3. Okay. It needs a key again. Let's copy this key and paste it. Please re-enter this passphrase. Okay. Did I copy it wrong? Copy. Paste. Okay. Let's ls. Do you see there are some files here? Code 3 ascension, code 3 txt. I think it has to be code 3 and with this. And here, no, it is wrong. Code the original message. Let's go with this comment. Symmetric cipher algo, and then symmetric cipher algorithm name was, what was it? Camellia 256. And what is our target? Code all 3. Yes, this one. We need the key again. Copy it and paste it. Come on. ls. This one seems new. Let's read it. It's not readable. Interesting. Did we broke the system? Let's read it again. Oh, we can encrypt. Actually, they are for encrypt. You can use the decrypt output. Okay, it's my mistake, guys. Sorry. I should just copy it and then coming here. You can't read. Let's clear. Okay. Come and paste it here. Output original message 3 and our cipher algo. Is it right? Cipher algo. Okay. Camellia. Okay. Decrypt code. PG. Come here. Okay. Paste it. And now ls. What is the new one? Original message txt cat original message txt3. You must understand. Now as you can see, we can read the message because it's a clear text format. To solve these types of questions, of course, you have to be careful. I did lots of mistakes here. Sorry for that, but let's say it's a experience. Okay, forgive me. Anyway, we can move on with the third part. It's a long part, but to solve these questions we will need some basic comments. You can read all of the instructions here. It is simple actually for practical questions. Bob has received the file ciphertext message sent to him from Alice. You can find the key you need in the same folder. What is the first word of the original plain text? So we have to decrypt it, right? There is an encryption file. So to do that we have to go task 3, clear it, make it ls. As you can see, it seems like our target, and they seem like our parameters. So to solve the first questions, we have to type the comments that TryHackMe gave us. Now I'm trying to remember them. So decryption, decrypt, okay. In cipher, it is our target. In key, with what is the key? Private key Bob's, and the output, let's say decrypted txt. Okay, the logic here is, let's read it, the scenario again. Bob has received the file from Alice. Okay, so Alice sent a file to Bob. You can find the key you need. Okay, if Alice sent a file to Bob with a public key, okay, with Bob's public key, we will encrypt this message with Bob's private key. Okay, as you can see here, we are using OpenSSL decryption. We will decrypt it with this target, and in key with Bob's private key. Okay, so press enter, ls. Decrypted cat, decrypted mask, txt. Perception is strong and sight weak. In strategy, it is important to see distant things as if they were close, and to take a distanced view of close things. Miyamoto Musashi. What is the first word of this paragraph? It's perception. And now let's go on with second question. Take a look at Bob's private RSA key. What is the last byte of P? So there is a short description here. The values of P, Q, and E and D, they are respectively. Okay, to see these parameters, we are going to have to use these comments, which is OpenSSL RSA in private key, Bob and text, and no out. Okay, as you can see, there are lots of data here. Let's make it bigger. Come on. Okay. Now, what was the P? Private exponent. Prime 1, yes. Prime 1 is P. Prime 2 is Q. Modules is N, and public exponent E, and private exponent is D. So prime 1 is for P. What is the last bit of prime 1, which is P? It is E7. Take a look at Bob's private RSA key. What is the last byte of Q? Q was prime 2. Let's go with prime 2. It is 27. So we inspect Bob's private key and find these answers. Let's move on with task 4. A set of Diffie-Hellman parameters can be found in the file dh_param.pem. What is the size of the prime number in bits? Okay, it is task 4, right? So let's go to the task 4. Task 4 clear ls. Here our file. How we can read it or learn some details about it. We are going to use this for this file text and no out again. I didn't memorize these commands, guys. I'm just reading from the article, from the paragraph. Okay, it is true, right? Yes. Let's press enter. There are some informations here, like the hash parameters. It is 4096 bit. It is size. We can see it from the output. And what is the prime number's last byte, least significant byte? It has to be the last parameter. Yes, 4NF. 4NF. Let's go to the 5 question. 5 part. Okay, 5th part actually. Sorry. What is the? We have some hash operations here, so they are basic. To do that, let's move on to the task 5 clear ls. Okay, we have a file here. What is the SHA 256 checksum of the file? Okay, let's checksum it. SHA 200. Okay, so order JSON or order to JSON? Order JSON. Okay. As you can see, it is our answer. You can copy it and just paste it here. Open the file order JSON and change the amount of. Okay. Nano open order JSON. The thing that we have to see here is if we change a single bit, a little single bit, okay, the all hash is going to be different than before. Okay, it was 1000, but now, sorry, it was 9. Yes, it was 1000, but now I'm making it 9000. Control O, enter, Control X, and then let's take SHA sum of this new file with just a little bit differentiated. Okay, we changed only one letter, only one number actually, from 1 to 9, and now let's can you see the difference here? Only one number is different from others, but the all hash changed. They are totally different. They are not acceptable. They are not recognizable anymore. Anyway, let's go to the last question using okay, what is the okay, it's a new subject. You can read from the text, but to do last question we have to have these comments. What is okay, actually it is enough. Decay. Okay, and what is the target order.txt, and with this key let's type it here, key, paste it, enter. HMAC command cannot found. It is was it like that? Yes, was it like that? It is like that, guys, sorry. .txt and key 3 RFD FC, like that. Okay, can't open key. It has, because it has to be like that. 3 RFD FC and the order.txt. It is our final answers. Sorry for the loss of time. To calculate the OK, you can use this one, this one, this one. Sorry. Okay. I had to use this command. You can see the mistakes that I actually made. You can see the reasons of it. Anyway, let's move on with the sixth part of our section. On the attached box, you can find the directory for this task located this room. Okay, alternate. Okay, what is the size of the public key in bits? You can use the following command to view your certificate. So we have to view our certificate, guys. Let's copy it. Okay, ls cert pm. Okay, OpenSSL. Okay, it's true, it's cert pm, yes, and press enter. You can see our certificate here. It begins here and ends here, but the information about the certificates here starts from here. There's a question about the last usage date. It is the 2039. Second question's answer. And the size of it, where is the size of it? As you can see, 4096. This one and this one. Till which year is the certificate valid? Okay, let's move on this. You were auditing a system when you discovered that the MD5 hash of the admin password is like that. What is the original password? To solve this question, we need a tool, or we need a web application to solve, not solving actually, to create a rainbow attack for this MD5 hash. And the necessary websites or tool is given in the hint part. Let's open it. Okay, come here. Where is it? Let's copy this hash. Come here and paste it. Oh no, not encrypting. No. We have to decrypt it. It's already encrypted. Okay, the answer is QWERTY 1, 2, 3. Okay. Here we don't need any answer, and here we don't need any answer. I have lots of mistakes here, guys. Sorry for that. Like I said before, I didn't memorize the answers. I'm trying to solve with mistakes, or with the correct answers, with the correct ways. we can say that we have some experience, we gain some experience with these mistakes, and we can think like that. And that's all I was going to say. Thank you for watching. I hope it will be helpful for you. See you on the next videos. Take care of yourselves. I wish you a nice day. I wish all of you a nice day.